Welcome to this programming tutorial, but instead of a tutorial, this is actually more of a walkthrough. This topic is about conditions and branching. When we say walkthrough, we're not going to be discussing the basics of if statements, how to write them, what are the possible errors, nothing like that. We are going to actually solve a problem and hopefully see how do you actually apply the concepts of conditions and branching into your programs. So our problem for today is the number reader. What is this about? Remember how you were taught how to read numbers? So if we're going to create a program, we will have to limit the inputs to 1 to 999. So let's say the user enters 463 as one number. The program must display 463. Let's look at the sample run to have a better idea of the program. When you have an exam, this is what should help you to analyze what the problem is about and what the program should do. For example, here, it shows you how many inputs and outputs are actually expected. The program outputs the word equivalent and accepts only one input and an integer at that. The other sample inputs are designed to help you understand the nature of the problem. Like, the program must be intelligent to figure out that it's only 2 digits, so that we will not see 056, for example. And then, same with 807. We're not going to see 807, but rather just 807. So that's the idea of a sample run. Let's look at the algorithm. Algorithm is simply just a solution. Okay, you have a problem. What is your solution? One approach is actually the easiest. We're going to create an if statement for every possible input. If we only have an odd-even problem, there's not much problem about that. But here, we actually have 999 possible inputs, and with the scenario of having invalids, we're going to have around 1,000 if statements, and that's not going to be fun. So we're going to try a different approach. Earlier, we mentioned that we're going to accept an input, and we're going to call the nextInt method. So now, how do we actually get the digits? If you remember how to learn reading numbers, we were actually taught the decimal places, that a 3-digit number has what you call the hundreds place, and a 2-digit number has tens, and 1 has simply ones. So if we apply it to our code, it means we're going to be dividing the number into 3 different digits, representing their decimal places. We'll have something like this. So I'm going to declare a new variable, the hundreds, actually 3 new variables, the hundred, tens, and ones, to make my code much cleaner. The next step would be to figure out what am I supposed to display. So depending on the hundreds, we can get 0, 1 until 9. So depending on what the result is, I will be displaying a certain input. So we can have something like this. Right, and we're going to have this until 9. But I don't want to write a bunch of print statements, so I'm going to declare a string like this. It's always a good idea to initialize your variables with a starting value. Usually if it's an int, you will have 0 or 1 depending on what you actually want to do. And for others, like a string, you will have this empty string. And we're going to change it to this. And we're just going to display the value of output at the end of our code. Okay, then we will have this one. Notice how I use an else if instead of just simply an if. The reason for that is because if this was an if like this, when this is true, Java will still check if this is true. Now, if Java was your secretary, would you want your secretary to be like that? It's a dumb secretary. Why are you even checking for 1 when it cannot? Why are you checking for 2 when it cannot be 2? Because it's already 1. You see the point? So we're going to use an else if for that. Now, we're going to be doing this for the other digits, tens and... Okay, notice I started with a 2 for tens because we have the special case of 11 to 19. Like, you don't read, we read as if 119, we read it as 119. So we're going to tackle that special issue. You can solve a programming problem incrementally, so no big deal. So we have this, okay, we have the ones. Okay, now let's try outputting. See, this is where the variables concept come in handy. So let's try to run this. Say we want to enter 300. Right, it's correct. Yay. Let's try another one. 317. What's the output for this? Now we have a problem. Clearly, 317 is not supposed to be just 7. It's supposed to be 317. But we know that this part was working earlier, right? So there's something wrong with our code. One way, when you look at debugging, it is frustrating, but that's not the point. It's something like a detective work. So your outputs here are your clues as to what is actually causing the problem. So to do that, maybe it's a good idea to check, are we actually entering these if branch? This is actually one branch, and this is third branch. Okay, one, two, three. You have 3 branches so far in our code. So we want to check if it's actually entering. So to do that, we should get an idea of what are we getting from these values. So I will be doing something like this. I'll print the hundreds, tens, and ones and run the code again. Plus input 327. So apparently we are correct on this part. Okay, so now we know that this is not the problem, it's something to do with here. Now, this is where your tracing comes in very, very handy. You have to know what your code is doing even without a compiler, and this is why we're teaching this in class. So let's look at the tens place. So it's 2, it should actually go here, right? So is it going here? One way to do that is to print a statement inside the if, just like this. Okay, we put a print statement here just to check if it's actually entering this statement. Of course, I know the answer, but this is a walkthrough, so I want you to learn how to actually debug your own code. Alright, so 327. Oh, okay. See the here? Right, funny. Anyway, this part is actually correct. The it must have reached this, and the 20 actually should have appeared. What's a closer problem here? Now, this little bug is about the concept of assignment statement. This is from topic 1. Remember how variables can only take one value at a time. When it reached, this would be true, right? Because the 100 is 3. It got 300, and when it reached this part, the 300 was replaced by 20. And ultimately, when we go to here, it was replaced by 7, which is what we have here, only 7. So be careful of your assignment statement. So apparently we don't want to overwrite. We just want to append, to actually concatenate. So what is the operation for that, if you remember? It is actually, yes, it should be like this. Remember? Well, let's fix it. Okay, so I added the concatenation like this, and in fact I can remove this because we're done debugging this. So, right. Now, I have a question. Do we need to put the plus here? We can, but it does not really make a difference because this branch will actually be read by Java first. And we're not going to be concatenating, right? So we can leave this as is. So let's try to run it. How will it work? 327. Alright, now it's pretty correct. Just looks ugly. How are we going to fix this? I can put it here, a space here. Yeah, that would work, right? and another space here. Okay, I'm going to put a space here, and I change the capitalization also. Do I need to put a space here? This is the last digit, so apparently there's no need. Let's try to run. Run the program, I mean. So 3 to 7. There! Now it's correct. But this part is ugly, so we'll remove it. When you remove debugging codes, I recommend that you just simply comment them out. Like this. Okay, so now we have a partially correct code. Now how are we going to put the special case of 11 to 19? Tune in for the next tutorial for that part. Thank you.